Okay, thank you. Good morning, everyone. And this morning, I'm happy to share my research with everyone. And my presentation today covers some of the research I've been doing in the last 2.5 years. It's just a part of it, so it's very short. And then it also shows some of the things I'm currently working on and I plan to work on in the next 1 year. So I title it Physical to Virtual Twin Connectivity in Human Digital Twins Network. And HDT, as we call it, is a rapidly evolving cyber physical system. Is a type of digital twin, and I'm going to talk about that. But in this system, we have an issue of communication, and so this is what I have titled Physical to Virtual Twin Connectivity. So this is my outline for this presentation. I will introduce you to the concept of human digital twin, or HDT. I will call it HDT most of the time, and then I will introduce you to that, and then I will present the architecture of it that we have proposed in the past month, and then I will introduce a solution that we call secure projected learning for this HDT. Then I will present some another solution that I call predictions for ultra reliable low latency, which is also required in HDT. Before I talk about the PT status generation, I will mention a few things that I plan to pursue in the coming year. So generally, HDT aims to replicate virtual twin of human being. So that is what the aim of HDT. And this started from the idea of digital twin itself. In digital twin, the aim is to create a virtual twin, which is a true replica of the physical twin itself. So in human digital twin as well, the aim is to create something that we can call a virtual replica of human beings. So it means if I am in the physical environment, in the real life, so the aim is to create a twin brother for me that is in the digital environment. So this is the aim, and at this moment it looks very complicated, but this is what we know as very possible. And there are a lot of research in this area, but at this moment, when we started in this area, there are less than 3 people that are working on it in the entire research space. But today, yesterday I searched, I saw more than 1,500 papers already published in this area. So, which shows that this area is gaining attention. But this is the goal of HDT, and I will show you how this idea started. In 1917, NASA used a peering technology on Apollo 13 mission. If you have watched a movie on Apollo 13 mission, you will see because they were in space, they were going to the moon, and they had a problem. They couldn't reach the moon, and they must get it right, otherwise they would die. And this was the first time something that looked similar to digital twin was demonstrated. They didn't call it this name. In fact, in 1977, they developed their first flight simulators with simulations, and their aim was to know what can make a plane to crash in turbulence. And it didn't make sense to them to design, to deploy a real-life plane, put human being there, and go and crash it. So they were looking at an idea on how to do that, and so they developed the first flight simulators in 1977. But they didn't use digital twin until 2002, where Dr. Greaves introduced this concept formally. And we have this first set of papers published by NASA and United States Air Force in 2011. And in 2017, it was listed among the top 10 technology for the future by Gartner, a leading research industry company in the US. In 2022, we have some pioneering papers published in this, and this was where our first paper was written on human digital twin. And in this paper, this was the first paper that introduced the architecture of human digital twin itself. And most of the work before even that have used digital twin, just use digital twin, digital twin, just like the way people use AI now, you put it in every area, and so they were just say, okay, we can use digital twin to do this, to improve this, but no one has even talked about this digital twin itself. So we are the first to propose this architecture, and in this same year, we have many companies like Siemens, Philips, IBM. They started to look how they can commercialize this idea. Following at the end of 2022, we wrote a new paper which introduced the concept of HDT from engineering perspective, and this was the first ever paper that was written on human digital twin from networking perspective. There was no paper on that before that. So in 2023, we have so the area became to getting a lot of attention, and we have HDT. It is an European ecosystem that was set up in Europe, and they were trying to build a roadmap towards its realization. And I have something here. This is their website because they started in 2023 and they are moving very fast. They call it virtual human twin. So you can see some people call it human DT of human, something different name, but it is what we call human digital twin. It's the same. And their aim is to focus on 5 areas. They want to see how they can use HDT to tackle cancer, cardiovascular, intensive, and so forth, and they are working on it. I'm not aware of any initiative in America on this, but I know Europe is going very fast on this concept of human digital twin. And after them, we also have many industry, many companies now. They are trying to see, okay, how can we use this? How can we develop human digital twin? How can this concept be developed? And I must say that for me, even as I'm not working on I'm not limited to only human digital twin. I work generally on digital twin network. It means that my applications is not restricted to only healthcare. So I work on every other aspect. But for this paper, when we started, we need for this work, when we started, we need an application area, and so we chose healthcare because we felt that we look promising. So last year, the paper, the first textbook on was written by Professor Peter and Ruger. So they are both in Europe. They call it Virtual U, and this were written from social scientists perspective, and they aim to see, is this possible? No, this is the first question people will ask. Every time I've presented on this, and people ask, this is not possible, or is this possible? So why do we need this? So this paper, this book was the first book written on it, and they discussed whether it is possible and what we can gain from this. Of course, they concluded that it is possible. This is possible, of course, in the research, anything is possible. But the question is, how long will it take to develop virtual human being? And so this was the first book that was published late last year. Early this year, we published our first book on it. I call it Human Digital Twin, Exploring Connectivity and Security Issues. And it was published by Springer as part of the book series that they had. And in this book, I summarize everything I've been working on human digital twin. And for me, I focus on the connectivity and the security issues in human digital twin. As I'm going to show today, I focus more on how the sharing of data between the physical environment and virtual environment can be made securely without compromising other requirements that I'm going to share. So in healthcare, we can say we have 5 key application areas of human digital twin, and the first is for proactive diagnosis. If a virtual human is existing somewhere, then we can make proactive diagnosis, because this virtual twin is a true replica of the physical twin. So we can predict the future, we can look into it in the future, and this will be very interesting. Another thing that we think is the personalized prescription. And sometimes, what doctors use now is one-size-fits-all approach, where if I have, for instance, fever, so there's a medication for that, and so it works for everyone, they think, but it doesn't work really for everyone. And during COVID, most people got the vaccine, but some people had complications. Some people didn't have any complication. And this is why people were thinking personalized prescription will work. In this case, what we try to do is, if we prescribe several medications to your virtual twin, then we can see which one works better. What is the outcome of this prescription, and then we can know which one is the most efficient, and then we can prescribe this to the physical twin in the physical environment. Then we also have customized rehabilitation. We have preparatory surgery. Why surgery is important for them to know what are the possible post-surgical complications that may happen. So if they have already completed the surgery on the virtual twin, they can know what is going to happen. And where I was before, we had a company that we were working on with this, though the project has stopped. They wanted actually to look for this to train doctors, because they said there are some cases that are very rare to see in real life, and when they are seeing it for the first time, it is very complicated. So we started working on it for about a year, but then the project stopped for some reasons. So we can also use it for continuous health monitoring, and there are also other reasons, but these are the 5 that I have here. So this is the first, so here I present HDT on the edge of the network. One key question is, where will the virtual twin be located? Where? We say digital in the space. Where is it? In the cloud? Is it in the edge? The size of the virtual twin is expected to keep increasing with time due to what we call continual learning. And so it's get to a point that everything will at the end be complicated. How do we save the virtual twin for everyone? Amen. So we don't know. So here we propose edge cloud collaborations, and in here we think we can put the virtual twin itself in the cloud. We can put virtual twin in the cloud, and then we can deploy what we a compressed version of it in the edge, just to ensure that we have a fast response and low latency. And then this will allow us to have distributed computation, high bandwidth efficiency, and high reliability and robustness. But this is just an idea. I know it's debatable. So I move to the architecture. So because in the architecture here, I've also the technologies that we need that may be useful in deploying this. And in most of my works, and I've been using some of this technology regularly to prove this concept. And for instance, I have a data management, I have blockchain. Most of my papers have used blockchain, but I've modified this blockchain from the existing, from the common one that we have in literature. Also, for computation, we believe that we need edge cloud collaboration, because we cannot use only cloud, we cannot use only edge. So we have to find a way to integrate both edge and cloud together to meet this requirement. And for communication as well, we have now moved to semantic communication. I will talk about this toward the end of my presentation. This is currently what we work on, because we've looked at the existing communication methods, and they are not sufficient to meet the requirement of HDT, which I'm going to talk about in my next slide. So we move to what we call semantic communication, and we are looking at how we can make this work. For data acquisition, we have so many technology already existing, and this is a good thing where we think HDT is possible, because all of these technologies are already existing. The only thing is, can we just adopt them in the current form, or we need to make modifications to it to meet the requirement of HDT? And these are the special requirements of HDT, because we want to create a true replica of the physical twin in the physical environment. Then we must be able to capture high quality data from the physical environment. And this data must be securely transmitted to the virtual environment, either cloud or anywhere it is, which is very, very difficult, because again, humans are mobile agents. They are always moving. And because of this, data will be generated almost every time. Do we need to send this data every time? If we don't, then we cannot maintain an updated virtual twin, which means we cannot have a true replica. But do we need a true replica every time? If we don't need a true replica every time, then maybe we can relax this requirement. But at this moment, people make argument that if it is not a true replica, then it is not useful. And so they said, okay, we need to move the data every time. And because of this, it is very complicated to move data in real time without violating the privacy and security of humans themselves. Also, I also mentioned with time, because of the continuous learning that we have in the virtual space, the data continues to be sent to the virtual environment, and then there is huge data storage problems. How do we save this data? What happens after a long period of time? So people have argued that maybe we can delete some data. Some people say, someone proposed a deduplication attempt, that maybe we can deduplicate data if our data looks similar. So maybe I can delete my own, and then when I need that, I can use your own data. But we don't know whether this will work, as all these research are still at the elementary stage. So there are many problems with this, but I focus on how to achieve this extreme ultra reliable low latency communications without compromising data security, privacy, and integrity. So this leads me to my first solution, where I proposed secure federated learning. It is not really federated learning as we have in the literature. It's what I call federated multitask learning. I modified completely the architecture of the federated learning because it cannot work for HDT. In HDT, we have multiple people, different people, and they have different requirements. Each person is unique, and so we need to personalize it. And so in this framework, I try to modify that, because the goal in conventional effort, federated learning, is to have a global model, to have a global model that minimizes loss, something like that. So, but the goal in HDT is not like that. It's to have each individual virtual twin that is a true replica of the physical twin. So we cannot have a centralized model that captures everything. We must have multiple models that represent each individual or each part of individual. And so here I introduce this FML, and I'm going to show that in my next slide. I also introduce a new consensus protocol for blockchain. I call it proof of model quality. And we have other protocols like proof of work that Bitcoin used. We have proof of stake, proof of authority, so many words in literature. But all this cannot be used because they require huge time for them to validate any transaction. So we need something that is useful and that is very fast. And so I developed proof of model quality for that. And then I integrated differential privacy. This is not new. This is just straight where we had Gaussian noise to the data just to maintain some privacy. So this is what it looks like. So this is the framework that I use to represent the FML, Federated Multitask Learning. So as you see here, so the aim here is to have the personalized model for each local aggregator or for each physical twin. So what is more important here is to have a personalized model for everyone rather than having a global model that minimizes loss. So, but the idea is to share models also between users. So we have two types of model here. We have what we call task-specific model, and we have shareable models. So shareable models are data that you can share with other people around you. So like for instance, we are in the same location. So the weather, some things like that are common to all of us, so we can share it. Or I can share my experience with you. So maybe if you have done something before, and then it can help you to also do your own. But task-specific models are something that are very personal to you. You don't want to share it. And so the shareable models are only the ones that are shared during this training here. And this is the experience as well that others can use to improve their training process to have a personalized model that minimizes loss. So this is the goal here, to have multiple models, unlike in the conventional federated learning. And so because we have changed the architecture a little bit, so the normal equation for for the learning process changed, and so we have these new equations. And I formulated this domain classifier to classify which model will be task specific and which one will be shareable as well. And this is just the basis for the equation for the differential privacy, where we use loss, where I had Gaussian noise to see that we can preserve the privacy of users. So I talk about the blocking. So I have a proof of model quality, and I use these equations to just demonstrate it. And then I need to calculate the time cost to complete one validation. And this is a function of the transmission time between the validators, the completion time, and the decision exchange time. And I also need to calculate the validation energy cost, because at the same time, we want to minimize energy, not only time. And so this is some of the things I try to formulate to capture this in time. So one thing that we need is, how do we know this makes sense? So we need metrics, and then we need to develop new metrics. We call it synchronization accuracy, which is addition of synchronization gap and federated learning loss. The loss is very easy to get. We just need to implement our model. So once we implement it, we get the loss. But the gap is very, very difficult to get. So because to get this, I use what I call non-preemptive single server last come first serve queue with a buffer size of 2 and queen display topology. So I show how it works there. And so with that, I was able to formulate this proposition, and then from here I was do some modification and assumption, then to arrive at this gap that we have here. So this leads me to this problem: long-term connectivity cost. How long? Over a long period of time, how much do we need to maintain the virtual twin, to send data from the physical environment to the virtual environment? And so we have these equations, and then one thing that is important is that then we observe that there are trade-offs between three things: accuracy, connectivity cost, and privacy. If we increase the number of variants during training, we can improve the accuracy of the model itself, but we also increase the connectivity cost, because the cost of training is huge. And so we see a trade-off between the cost and the accuracy. Also, between the accuracy and the privacy, we see that as we increase the proportion of noise in the data, we can improve the privacy, but that also compromises the accuracy significantly. And we also see a trade-off between connectivity cost and privacy. I would say, which would say that this makes this model very, very difficult to obtain. At the end of the day, the model looks this way, and the mathematics are okay. So the model looks this way. Then because it is impossible to solve this problem in closed form, so we use deep reinforcement learning to do this, and then we obtain these results. Interesting, the result perform better than any of the existing method, but it's still not good enough. And so this leads me to this prediction method. I'll just skip through it. In the prediction method, the idea is to predict in the virtual environment the state in the physical environment, and this can solve most problems that we currently have under ultra reliable low latency. If we can predict what we have in the physical environment, then we don't need to rely on the transmission of data itself. And so the idea is, if we make prediction here, then we can use the actual data eventually to validate the prediction we have made for the future, and then with this we can make some adjustment. So because of that, we don't need to send data in real time again, because the predictions are made in the real time in the virtual environment. And after making this prediction in real time, we use this to update the virtual twin themselves. And so when we have the actual data here, we can use that to validate it and make any update if we have to. So then, because we don't need to send data again in real time, we can batch them, and then this reduces cost a lot. And so we see that this one key thing to note here is that this approach reduces the experience delay to zero in most cases. And so the only problem we have here is the prediction error. So as you would expect, because we deploy a prediction system, that we are going to have errors. And can we minimize it? And so we have these 4 questions that we try to address in our paper, which is currently under review. And then we also make these key observations, which are also very significant to this prediction system. But it's what we believe can solve many problems in communication. People working on 6G can use this method, because we believe this is going to be the future of communication. We also noticed some trade-off here, and then we got a problem this way, and because of this trade-off, we got this ideas where I talk about semantic communication. This is my second to the last slide, and here we see that, okay, maybe we can deploy HDT model to help us so that we can reduce error from that. So in this case, we look at the system model that we have in semantic communication, and we see that we have single user keys where a user try to train a decoder. And then we have also one paper that have used these multi-user keys. And then we expanded this method to what we call Flesh. And here, the goal is to have multiple customized HDT model, and we have to train this. And this is currently, we are working on this. We also have like 2 papers under review on this as well. So this is how it looks like. Here we deploy HDT, we deploy semantic communications, and then we try to see how we can use this to improve communications, updating, and the learning process in the virtual environment. So currently, next node selection problem. I didn't have time to explain how this problem arises, but because of the learning process, we have node selection problem, which we're currently working on. I think we also have one paper submitted on this as well, and then. Also want to say how to reconstruct semantics. I didn't have time to talk about semantic communication, but it's a very, very good approach in communication that people are currently looking into. And I'm also working something currently on how to secure that semantics. So it's a very interesting area. So here I think I discussed that. So I'm planning also to look to design HDT enabled notation. I started working on this I think a year ago. And the key work here is how to use concept to manage notation of people, and this is very this is very possible. No, this is not you don't need 5 years to do this. In 1 year, this can be done. So the key thing is how to extract data, which how to represent this data, how to model this notation and security and implementation as well. So at least I plan to finalize work on it 1 year, 2 years here. So thank you.
Thank you. So first, I want to thank you. I'm sorry to rush you at the end, just because we have to catch another presentation we have today. So I have some question, but I will be the last to ask you this question. So I will leave it to see if somebody want to ask any question. Yeah, go ahead. Yeah.
Okay, so thank you for your presentation. So, going back to whether to keep, real-time updates on the digital copy of the human being. I'm wondering if there are any, findings, most especially that justify that perhaps maybe different domains or for different issues, you don't need real-time updates.
Yes. 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 In fact, yes. People, there are many areas where we don't need real time on this. There are many times. So people have argued that. So if we focus on application specific, so this is the application we are working on, then we say, okay, for my application we don't need real time of this, so I don't need to do this. We can move this. But then some people say, okay, what if we just design a framework that can handle everything? So this is a problem, but I want to think most applications would not require real-time update. But for some applications that require real-time update, then we need to do this.
Okay. Then that takes me to the second question, which is on the quality attributes. If you can go back to the screen on your quality attributes, where you were talking about the trade-offs.
Okay, I think.
Move back.
This one?
With a 3.
Yeah, move back.
Keep back.
Yeah. I think it's A.
Yeah, keep going.
I should keep going?
Yes.
Oh, sorry. My system is faster than.
Okay. Oh, no. You have like a triangle. Like
Yeah, 3 bubbles.
Remember that triangle?
Yeah.
So, looking at those quality attributes, because you talk about trade-offs.
Yes.
In your own study, what do you think is most preferable here?
Most preferable.
Yes, I mean, is it based on the domain as well? Do you see any correlation with the domain of application? To know, because I know you can trade off anything here.
Yes.
Yeah.
Yes. I don't think this depends on application. I think every application wants to reduce cost. You want to minimize cost. Even if you are deploying it either in hybrid or anywhere, you don't want to waste. You don't want users to wait maybe 10 minutes before they can receive output from the twin itself. And accuracy is very important. So if you deploy AI systems and they are giving wrong output, so then that is a big issue. Privacy. Humans will have problem with any system that include their privacy. So I think for any applications, the theory trade-off are very important.
Okay. All right. Thank you.
I'm here.
Samuel, thank you for the presentation. I don't claim that I understood half of the slides, even more. I got lost, along the way because that's not my research. But if you could go back to I don't know if slide number 1 or 2, I have a very basic question to understand HDT essentially. I'm familiar with digital twin completely. I did research when you have simulation environments that you want to have physical systems like buildings to be part of that modeling. Correct me if I'm wrong in terms of understanding of the applications and where HDT, why we need HDT essentially. Is it the case that we have emulators and simulators and then we have humans interacting with these systems and humans behave quite differently and we want to have sort of an understanding of these interactions in the simulation. So that's why we need to bring virtual twin of human into the equation.
Okay. Thank you for that question. So to answer that question, I start because we also have digital twin of everything. We have digital twin of industry, digital twin of machines, and it is different from just having data somewhere, run the data and have results because of the real-time connectivity that data twin brings. So data twin is something that should give you the correct state of anything at this time. So, for instance, for people that work in communications or to this vehicular stuff, one thing they want to do is, every time they want to make decision very fast, and so they want to in allocating resources. They want to know the exact resources that is needed at time t equals 1. Now, at this time now, they want to know the exact resources. So if you go to the emulator and say, okay, what is the resources that we need? We cannot get that result now. So digital twin is something that can give you the exact state of the physical environment in the virtual environment. So for the and so that was the idea. So that was the idea that leads to human digital twin itself. Because when I got to Concordia, so some of the research they have done in my lab was they may mention something that medical error is the leading cause of death. I mean, maybe there's one research that they mentioned from US that they said this, and then they were looking at how to do, because they had some funding on how to look into that, and this was how we started this idea. And when I look, what we think is, if you have something that is a true replica of you, that is like you, and for instance, they want to prescribe something to you, we don't know what can happen, whether this is going to work, whether this is going to be a disaster, whether this is going to be efficient. So what if something is exactly like you that we can give this thing to, and then we see the reaction? So we are so sure because this is an exact replica of you that if you give this prescription to this, it's going to perform exactly as it would have performed on on your physical self. So this was how this idea started. But as we move on, we see that even we can move beyond this. But the goal is to have something that is a true replica of the physical object. It doesn't have to be human. It can be machine. It can be plane. And NASA, they are using this a lot now. And from the Apollo 13 mission, you see that they need to create something that is a true replica of the guys in the space at that time. Otherwise, they are going to die. And so, and they were looking in real time to see what is happening in the virtual space, what is happening in the physical space. At this time, everything must be the same, must be synchronized. So it is not like a simulator or emulator somewhere that we just go put data and get result, but it is a complete entity that is a true replica of the physical environment. But why we need
but Sam, look at the that hierarchical graph that you have on the right. Yeah, HDT consists of emotion, cognition, thoughts, body movements, stress, all of these components. I work on emotion, just one component, and we are struggling quite significantly because everyone is expressing it differently, and there isn't really that much the intra-class variation, inter-class variation. Everything is quite complex, and I'm just I see the vision, I see the research, and I love it, but I'm just wondering how realistic it's going to end up being, because this is quite ambitious vision. Human is not like a machine. Machine is man-made. It's physics-based. We are not physics-based. A lot of physics-based modeling in my research has been replaced over time. In computer vision, machine learning, all of the physics-based systems which were math-based, originally engineering-based, they've been replaced over time. I'm not saying that physical-based systems are bad because they have a solid math background, but I'm just wondering, is it quite a visionary research that is at infancy, or we are going to see some tangible results soon?
Yes. Like I said, but this is possible. If you read the book Virtual, so that was not written by me, so by some, but people I don't even know. This is possible, and the emotion is what made emotional cognition are what makes human different and complicated to model. And so this is why we need personalized model. You see that when I talk about further learning, I talk about the need to get personalized model for everyone. So we can model if over time. Now maybe we don't have. I can't show you a framework that's true because I don't know everything. I've not done everything, but this is what makes human unique. And emotional modeling is what is possible for individual person if we study how you behave, which is personalized to you. So it means we cannot extend it to another person, but for you, we'll be able to capture it over a long period of time. So these are things that are possible. But the question is, how long will it take? But they are very, very possible.
Thank you. Before I go to Russell, I will not ask now, but I want to say something that anything start fancy, and then it will be realistic.
Yes.
So this is always like this. Russell, please go ahead.
Oh, Ismail, how much time do we have?
We have time for you, Russell. Go ahead.
Okay, I would join everyone and just express gratitude for the presentation, Samuel. Thank you very much. The thing that I notice right away is just all of these beautiful, complex figures that you have in all of your slides. And so when I see all of that, I immediately want to think, well, this would make amazing kind of simulations that I see students, they could immediately jump in and start to program simulations of some of this stuff to start to understand a little bit better and jump in on things. So if you could choose like one of the visual figures that you've got on your slides, a small part of it, what would you choose to have simulated first?
For this side, I assume your question is in the context of UFV. So this is also something I'm trying to battle with. So most of this work cannot be done by undergraduate students. So that's why in my last slide I show human digital tools for notation management. So this is what we can handle at this stage. So this does not require advanced mathematical knowledge or programming skills to do. So that's why at the end, I showed that this is what I plan to work on the next year. So that's only requires them to know how to, develop HAB, then other models, they are already existing, and I have an idea of how to integrate all this very, very clearly. But to go deep into the into the modeling of this structure, I think it requires people that are very experienced in the research. So that is why I think my last slide I showed something like that. I showed if something I can do now is this last part. This undergraduate student can handle. This is possible at this time. Data extractions is what they can do. Of course, I can guide. I will guide them, and I have a clear idea of how this can be done. Now, I have idea of how this can be done, and so this is what we can do at this time.
Well, I would love to talk to you sometime and just work through if there's students that I have in my class right now and Comp 360 with graphics, if they could simulate a little bit of like an imaginary person, and if they have some of these nutritional requirements, and then visualizing the human digital twin experience that you presented to us, I think that would be great to have them start thinking about it.
Just one quick question, like what was the motivation for having multiple copies of the digital presence, and then you were kind of using a validator, and then you had, I think in slide 15 or something, so you had these multiple copies of the this one. So this LA, LA1, LA2, so these are the what does LA stand for actually?
Local aggregator.
Local aggregator. So you have like so if I understand, there are multiple copies of the same data, right?
Yes.
So is it, what is the motivation? Is it because of the cloud computing or the edge computing, the different regions they are stored?
The motivation is to reduce the size of data we send. So if, for instance, I only have updates on my environment, nothing has changed concerning my head, so I don't need to send everything here. I just need to send a segment of my part that has changed. So that's why we have different local aggregator. So for each section of data,
it's not the whole data, but
it's not the whole data,
just changes.
Yeah, just segment of each environment.
So my question here is, as far as I can understand from your presentation, you are working, proposing a framework to communicate all this data regarding that digital, like say digital identity.
Yes.
Which it has all this information, how we can transmit and communicate within this framework. But what about the data warehousing and modeling later? Is it not part from this framework?
Modeling data in the virtual environment.
Yeah, how? So is it part from this framework, or this framework focus more on the communicating of the data, how we communicate this data?
The framework is part of the framework, but my work
Yeah.
that I've done focus on the communications aspect.
Yes.
So, but the modeling for data
Yeah.
is also part of the framework, but I have not worked on that.
You are not working in this, but somebody else is working in this project. Because this is my domain where I'll be interested also in this.
Yeah, I'm not sure anyone
So
is currently working on it now. I'm not sure.
Yeah, that's good. Then this can be an open discussion, because I believe later we need the data modeling part very important after having warehousing all this data.
Yeah.
So I will be also with Russell. I will knock your door to talk more about it.
Thank you.
So thank you so much. We are happy so much to have you here.